Hello, welcome to Impulse Mathematics. Now we are going to start a new session here that is called logarithm. Okay, so most of the students have difficulty regarding that, and I'm decided to make a video with the chapter, this logarithm. Now, before going to start some important problems regarding that, we are going to discuss what is the concept and what is the history behind the logarithm. So actually, the logarithm comes with the difficulty which we have in the indices. That is, suppose we have a 2 into 2 into 2, that is equals to 8. So basically, if I ask you that 2 to the power 3 equals to 8, we all know about it, right? Now basically, if I ask you that 2 to the power x equals to 8, then what is the value of x? Now definitely somebody can answer that 2 to the power x, that is equals to 2 to the power 3. So by comparing, we can say x equals to 3, isn't it? Now what if that I'm asking you that 2 to the power x equals to 7. Now what is the value of x? The question is, what is the value of x? Now to answer this question, we faced so many difficulties because the value of x will come in the decimal, right? But we have to define that. For this, the logarithms come into play. That these indices we can express in terms of logarithm. How? That is, if we have an index, right, like this, indices like this, that is a to the power m equals to n. So these can be expressed in terms of logarithm. What is that? That these can be expressed like log a base n, that is equals to m. Okay, so here you can see that the value of m we can find out. That means the value of index we can find out. Okay, so that is the purpose of logarithm. Now we write down some basics formula regarding this, that is formulas for the logarithm, right? Formula used in logarithm. Let us see, so which formula we are going to use. That is, so first formula we are going to use, that is called log a base b. If it is there, then we can express this in the form of indices, that is a to the power b, and that is equals to x, suppose. So a to the power x, that is equals to b. This can be expressed in terms of logarithm. Now this is the first one. Now second one, if I ask that what is the value of then log a to the power 1. Now suppose we all know that a to the power 0 equals to 1. So if I express this in terms of logarithm, then what happens? That log a base 1 equals to 0. That means whatever the base it is, because a is the arbitrary element here, a is here, this one is a is arbitrary. Anything, a can be anything. So whatever the value of log 1, that is always 0. So log 1 is always 0. Log 1 is always 0. That is the formula. Okay. Third number, as we all know that a to the power 1, that is equals to a, right? So if I express this one, that is log a base a, that is equals to 1. So if the base and the value of the logarithm is equal, here you can see this a, this is also a. If this thing happens, so it will be 1. So here you can see that if I give you some examples, that is log 2 base 2, that is also equals to 1. So log 10 base 10, that is also equals to 1. Log 3 base 3, that is also equals to 1. So whatever, if the base and the value is same, the log is 1. Okay. Next one, if I tell you one thing, that log a, that is given, suppose this one is given to you. Now here no base is given, so instantly by default we need to take that log 10 base a, it is given. Okay, in the arithmetic problem, in the algebraic problem, what happened, that we usually denote, and this one, that base is 10. Usually consider the base is 10. Okay, why we consider? Because this is standard form of logarithm. This is called the standard form of logarithm. Okay, now you will remember one thing, that when we discuss about the standard form in exponent, right, or indices, then we'll actually express like this: 1 point some decimal part, right, into 10 to the power some indices, right? Suppose a point b into 10 to the power m. Like this we express. This is the standard notation of expressing some element. So that's why this 10 has come. Okay, that's why this 10 has come, and this 10 as we express the base of the logarithm in the standard form of logarithm. Another one natural logarithm is there, that is actually used in the calculus, that is called log e base some values, that is log e, that is called natural logarithm. Log e base suppose a, that is called the natural logarithm. this logarithm actually e base a, that is also called as like this ln a. When ln is given, that means log natural. That time we need to consider that the base is e. Okay, so that is another part. Now we'll move to the some other formulas, that is some advanced formulas regarding the logarithm, or you can say the operations on logarithm, how we'll operate the logarithms, logarithmic values. Okay, that we need to know. So some standard law, we can say that some standard law of logarithms. So let us see what the laws we have. First one, that is log a base mn, that means m into n. So this can be written as log a m plus log a n. Okay, and this is true for the not only for the two variables, this is true for the 3, 4 and the multiple variables. Like if we extend this formula like log a base m1 m2 dot dot mn, okay, so that can be written as log m1 plus log m2 plus dot 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 so on log mn. Okay, so that is the extended formula. Now log a base m by n, so this can be written as log m minus log m. Okay, log m minus log m. 3 number, log m to the power n, that is a very important formula. Log m to the power n, that is equals to n log m. That means you can see here this m is the index, is in the index of the value of the logarithm. Now this can be shifted to the left side of the logarithm, that is multiplied, that m this n is multiplied with the logarithm. But don't write n here. Okay, no, this is not possible, because we need to write the n in the left hand side, so that it will be represent that n is multiplied with the logarithm. So here the all the bases I do not consider here. Here I must write the base, that is a base is there. So here this base is a, this base is also a. Here you can see that a, so all the bases are a, right? So here also the base is a, so this all the bases are a. Okay, now here if the base is a, this base is also a. Okay, so base will not be changed here. Now with that formula, with this formula, we can have some deductions, like if log a base a to the power x is there, so this can be written as what, x log a base a, so that is equals to x into 1, that is x, right? So these can be the deductions of the formula. Now next one, 4 number, that is the advanced, this is also advanced formula, that is base change, base changing formula, base change. For how we change the base, that is, you can imagine one value is there, that is log a base m, suppose. Okay, now this can be written as log m divided by log m, log a. Okay, now you can see that here is the base is a, so I write here the value a, here base the value is m, here also I wrote the value as m. Now this one do not have any base, this one do not have any base, but we have to choose the base according to our convenience. Okay, we have to choose the base according to our convenience. If I want the base is 10, then we'll write 10 here. Okay, but if I want that value is, the base is we need, that is a, then we can choose the value is a. Okay, so base value we can choose according to our convenience. That base we will choose according to our convenience. Okay, the base we will choose according to our convenience. Next, so if we discuss about the deductions of this base change, so we'll have so many things, like if I talk about log b base m, so this can be written as log a base m into log b base a, right? Another one is, suppose we have log b base a into log a base b, we have, so this can be written as 1, because you can see that if I change this base here, that means like this, if I write log a by log b into, here will be log b by log a, so this and this will cancel out, it will be 1 only. Okay, so like this it happens. And with that note, we can write this one also, that log b base a, this is equals to 1 by log a base b, right? If this, from this we can say, this implies actually, right, this implies this formula. Okay, now we'll move to some important problems regarding logarithm. that mostly we're going to solve some problems that we'll write the question first, then we'll solve. Okay, so we'll write here that problems on logarithm. Problems on logarithm. Okay, now we'll choose one book for that. Now the book we'll choose, that is ML Agarwal, and the exercise 9.2. Because 9.1 I think mostly we can solve, because that is the basic formulas only we have, and 9.2 we'll choose, and that is the page number 175. Okay, let us see from the first problems, that is the question number 1 that log a cube minus log a square. Okay, so that is equals to, we can see we need to simplify the following expression. So here you can see that the what is the in the index 3 is there, here index 2 is there, that can be shifted to the left side of the logarithm. So we can write this one as 3 log a minus 2 log a. Now you can imagine that 3 log a, if 2 log a we subtract it, so only log a will remain, right? Log of a will remain, or if I take common as log a, so it will be 3 minus 2 only. So what happened, that this is 1, so log a will remain 2 number, that is log a cube divided by log a square. Okay, that is log 3 log a. Now divided by will not write like this, will write in the fractional way. So divided by log a, that is 2 will be left side of the logarithm. So this part, we can say that this part and this part will cancel out, we'll have 3 by 2. Okay, next 3 number, log 4 by log 2. Log 4 can be written as log 2 square divided by log 2. Okay, so this one will have 2 log 2 by log 2. This log 2 and log 2 will cancel out, we'll have 2 only. Next 4 number, 8 log, sorry, here we'll have log 8 into log 9 and divided by log 27. How to solve that? Now log 8 can be written as log 2 to the power 3 into log 3 to the power 2 divided by log 3 to the power 3. Okay, now we'll shift all the indices, that means this index, this is index, this is index, and this is index. Here you can see that all the problems were, whatever we are solving, no base is there given. So we are not going to write any basis, because we consider that the base is 10 here. Okay, and we imagine that the base is 10, so we need not to write the basis. Okay, so here what happened, that this can be written as 3 log 2 into log here we'll write 2 log 3. Okay, divided by, here we'll write 3 log 3. Now log 3 and log 3 will cancel out, 3 will cancel out, so we'll have here only 2 log 2, and that would be the final answer. Now next we're going to solve the 5 number, log 27 by log root 3. Okay, so log 27 can be written as log 3 to the power 3 divided by log 3 to the power, now root means root 3, that we can write as 3 to the power half. So we'll have this one like 3 log 3 divided by half log 3. So you can see that log 3 and log 3 we can cancel out. So what we will have, that we are going to write log 3 by half, that means 3 into 2, that is equals to 6. Okay, next 6 number, last for the question number 1, that is log 9 minus log 3 divided by log 27. Now log 9 means log 3 square minus log 3 divided by log 3 to the power 3. Okay, here we'll write 2 log 3 minus log 3 divided by 3 log 3. So 2 log 3 minus log 3, that is log 3 only, divided by log 3 log 3. Okay, so this can be cancelled out, 1 by 3 will become my answer. Next, two number. Question number 2. 2 1. That is, the question is here log 10 divided by this. Okay, so how to solve that? Log, we'll write here 10 divided by this. Okay, now you can see that log m by n, what is the formula of this? We'll have now log m by n, that is log m minus log n. So we'll use that formula only here. So we'll write here log 10 minus log this. Log 10 is 1 minus this one is actually log 10 to the power 1 by 3. So 1 minus 1 by 3 log 10. Okay. This can be written as 1 minus 1 by 3 into 1. So it is actually 1 minus 1 by 3, that is equals to 2 by 3, and that is the final answer. Okay, so like this we are going to solve all the problems. Okay, next one. So now question number 2, that is 2 plus, okay, I'm writing like this, that is 2 plus half of log 10 to the power minus 3. Okay, so how to solve this one? The 2 will remain as it is, so half log 10 to the power, you can see minus 3 is there. So instead of writing this minus 3 here, we'll write this minus 3 in the left side of the logarithm. So what happened, that is we'll write the things like this, minus 3 into log 10. Okay, this we can write that minus 3 will be shifted to the left side of the logarithm. Now we'll write 2 plus half into minus 3 into log 10 is what, 1. So 2 minus 3 by 2, that is 4 minus 3 by 2, that is equals to 1 by 2, and that is the final answer. Okay, so next 3 number. 3 number, what is the question? We'll write that is 2 log 5 minus, sorry, plus log 8 minus half of log 4. Okay, so here we'll write 2 log 5 will write as it is, plus log 8 will write log 2 to the power 3 minus half log 2 will write log 4 will write log 2 square. So here it will be 2 log 5 plus this 3, that is 3 log 2 minus this 2 will be shifted, so half into 2 log 2. Now these 2 we can cancel out, isn't it? That 2 will be cancel out, so it will be 2 log 5 plus 3 log 2 minus log 2. Now these are the like terms, that 3 log 2 and 2 log 2. So 2 log 5 plus 2 log 2. 2 if I take common, it is log 5 plus log 2. Okay. Now you can imagine one thing, that this is actually the formula of log m plus log n. Log m plus log n. So what is the formula actually? Log m plus log n. We have the formula log m plus log n. That is actually equals to log mn, isn't it? So we'll use the same one here, that is 2 log 5 into 2, 2 log 10. So 2 into 1, that is equals to 1. Interesting. Now next one, that is 4 number. 2 log 10 cube minus, sorry, plus 3 log 10 to the power minus 2 minus 1 by 3 log 5 to the power minus 3 plus half log 4. This is the question we have. Now how to solve that? This 3 we can shift to the left side, so there is 6 log 10 plus this one also 3 into minus 2 log 10 minus this 3 also, so 1 by 3 into minus 3 log 5 plus half log, this one I will write log 2 square. So here 6 log 10 plus, sorry, this one will remain minus 6 log 10 plus this 3 and 3 will be cancelled out, so plus log 5 will be there because minus is there, minus plus, so and plus half into 2 log 2. These 2 again cancel out. You can see that these 2 terms will be cancelled, omitted, because plus and minus, and here we will write log 5 plus log 2. Same formula will apply before the previously will apply here, this one, so we'll apply same things here. That is log 5 into 2, that is equals to log 10, and this is equals to 1. So this is the final answer we'll have. Next, 2 log 2 this is the question. Okay, so how to write, you can see how to solve this one. 2 log 2 will keep same as it is, plus log 5 minus half. This can be written as log, we'll write here 6 square. Okay, minus, you can see log 1 minus log 30, we can write this one as formula like this. So 2 log 2 plus log 5 minus, this 2 will be shifted to the left side, so half into 2 log 6 minus log 1 is 0, so minus and minus, it will be plus log 3 into 10. 30 will write 3 into 10. Okay, okay, no need, you write here 30 only. Let us see how what can be done. So here you can see that if I shift this 2 over this one, so it will be 2 square plus log 5, and this 2 will cancel out, minus log 6 plus log 30. Okay, now this is log 4 plus log 5, and we'll arrange this log 30 here, and log 6 will keep like this, because minus is there, that's why we keep all the plus here. Now this is, you can see the multiples formula, if I apply that log m1 m2 m3 like this, we have one formula. So if I apply here, so it will be log 4 into 5 into 30, okay, minus log 6. So if I take that 6, 4 into 5 into 30, 6 will be in the denominator, so 6 5, now it will be log 4 into 5 into 5, that is 100. This can be written as log 10 square, or 2 log 10. 2 into 1, that is 2. Log 10 we are writing 1, why? Because the base is always, we consider 1, so log 10 base 10, that is 1. If the base is this one, log 10 base 10, that is always 1. Okay, that's why we are applying log 10 equals to 1. Sixth number, 2 log 5 plus log 3 plus 3 log 2 minus half log 36 minus 2 log 10. This is what we have. Okay, so how to solve that? We'll write here 2 log 5 will keep as it is, that is 2 log 5 plus log 3 also will keep like this, plus 3 log 2 minus, this one can be written as log half into log 36. This 36 means 6 square, so that 2 will keep here, so we'll write here like this, minus 2 into 1, because 10 is 1, no? 2 log 5 plus log 3 plus 3 log 2 minus, these 2 will cancel out, log, this one will write 3 into 2 minus 2 log 5 plus log 3 plus 3 log 2 minus, this one will write log 3 minus log 2. Formula, what is the log 3 and log 3? This will cancel out, right? Log 2 minus log 2, so we'll have 2 log 5 plus 2 log 2 minus 2. 2 if I take common, that is log 5 plus log 2 minus 2. 2 into log 10 minus 2. 2 into 1 minus 2, 0. So the answer will be 0 here. Here you can see this portion, we need to understand here that 2 log 5 is here, so we'll write 2 log 5. Now log 3 log 2 is here, so 3 log 2 minus 2 log 2, that is 2 log 2. Here we have to take 2 common, so it is log 5 plus log 2. Log 5 plus log 2 means log 5 into 2, that is log 10. Okay, that 5 into 2, that is 10. So log 10 is 1 and there is 0. Okay, I hope it is clear to you. Next, number, log 10, sorry, log 2 plus 16 log 16 by 15 plus 12 log 25 by 24 plus 7 log 81 by 80. Okay, let us see how to solve. Log 2 plus 16 log 16 minus log 15, okay, plus 12 log 25 minus log 24 plus 7 log 80 minus, sorry, log 81 minus log 80. log 2 plus 16 log, we can write this one as 16 log 2 to the power 4 minus 16 log 15 can be written as 5 into 3 plus 12 log 25 is 5 square minus 12 log that 24 is, you can write 8 into 3 plus 7 log 3 to the power 4 minus log 8 into 10, and definitely here will be also 7 log 2 plus 64 log 2 minus 16 log 5 minus 3 log 16 log 3 plus 24 log 5 minus 12 log 8 minus 12 log 3 plus 28 log 3 minus 7 log 8 minus 7 log 10. Okay, so the problem is laborious, please do it very carefully, otherwise there is a chance of mistakes. So log 2 plus 64 log 2 minus, here you can see that 16 log 5, okay, we'll write one more time, 16 log 5, simplification is important, minus 16 log 3 plus 24 log 5. Now this 8 can be written as 2 to the power 3, that 8 can be written as 2 to the power 3, so we'll write here 3 into 12, that is 36 log 2, okay, minus 12 log 3 plus 28 log 3 minus that 8 can be written as, this 8 can be written as 2 to the power 3, okay, so it will become 21 log 3 log 2, sorry, minus 7, so log 2 and 64 log 2, that is 65, and any other log 2 is there, so 1 plus 64 log 2, we can have 36, another any log 2, yes, 21 inside the bracket, and we'll write log 2 here. So we'll now find log 5, minus plus we'll write here minus 16, any other log 5 plus 24, so this one only log 5, and log 3 will find plus minus 16 and minus 12 plus 28 log 3 and minus 7 will be as it is. So let us see now. So here if I calculate this one, 65 minus 36 minus 21, that is 65 minus 57 log 2, and this one will have 8 log 5, and what we have, this one will be 0, because this entire term will become 0 here, because 28 minus 28 plus 28, so entire term will be vanished, this entire term will be vanished, okay, and minus 7 will be there, okay. So here we will write, this one will be 8 log 2 plus 8 log 5 minus 7, so 8 if we take common, log 2 plus log 5 minus 7, 8 log 10 minus 7, so 8 into 1 minus 7, 1, and that will be the final answer, okay. So 1 is the final. So that problem is little laborious but not difficult, I can say. Next, 8 number, that is 2 log 10. If you don't understand in a single time, watch repeatedly, you will definitely understand, okay. Plus log 10 base 8 minus half log 10 base 4. Now let us see how to solve that one. Now 2 log 10 base 5 plus log 10 base 2 to the power 3 minus half log 10 base 2 square. 2 log, all the bases are 10, so I am not going to write the base, plus 3 log 2 minus half into 2 log 10. This term will cancel out. 2 log 5 plus 3 log 2 minus 1. Okay, so now here we can write 2 log 5 plus 2 log 2, okay, plus log 2 minus 1. 2, if I go take common, it will be log 10 plus log 2 minus 1. 2 into 1 minus plus log 2 minus 1. Now 2 minus 1 plus log 2, that is, so 1 plus log 2, that is the final answer. Okay, next. Three number. Express each of the following as a single logarithm. Okay, single logarithm we need to express. So what is the question? First question is 2 log 3 minus half log 16 plus log 12. Here it is. We can write single logarithm, that means 3 to the power 2 minus log 16 to the power, okay, I'm changing the color here. Now here you can see that 2 log 3, so log 3 to the power 2 minus log 16 to the power half plus log 12. Okay, so here it is log 3 square means 9 minus log 16 to the power half, that is root 16, that is equals to 4, plus log 12 will keep as it is. Now log 9 plus log 12, meaning we can write minus log 4, we can separately write. So these have one formula, that is log 9 into 12, right, minus log 4. So we can write log 9 into 12 divided by 4, 4 3, so log 27, or you can write log 3 to the power 3, or we can say 3 log 3. Okay, so that is actually the single logarithm. Next, 2 number. What is the question? That 2 log this log this is the question. Okay, now we need to express that in single logarithm. How to express that? You can see that this one log 10 base 5 square minus log 10 base 2 plus log 10 base 4 to the power 3 plus 1. Log 25 log 2 log 10 base, here all the bases are 10, right, 4 to the power 3, that is 64, plus this one can be written as log 10 base 10, right, because we need to express it in a single logarithm. So write this one here. What we'll do, that you can see all the positive terms will keep in 1, that is 25 plus log 10 base 64 plus log 10 base 10 minus log 10 base 2. So it will be log 10 base 25 by into 64 into 10 divided by 2, because this is a subtraction is here, so it will be divided. Log 10 base 2, and this one will cancel out 5, so we'll write that one, that 125 into 64, right. So log 10 base 125 is actually 5 cube, and this one is 4 cube, right. So we'll have log 10 base 20 power 3, or 3 log 20. Okay, so that is the answer. So we'll solve some more problem in the next part. This is the part 1, and we'll have some like 3 parts we'll have mostly, and we'll finish the entire exercise of the logarithm. Okay, so this is the part 1. Stay tuned for the next part, because that part will be contained so many important problems. These are the basics part, you can consider as a basics, because we already discussed about what is the concept, how the logarithm has come, and we have solved already so many problems. Next part will solve some important problems, and we'll have the third part also, so stay tuned for that.